Now, I explain how to understand the policy in reinforcement learning. I put policies in reinforcement learning into three categories. First is the static environment. That means when we search the policy, the environment is fixed. For example, we are in this grid, we try to find a policy start from any cell in this grid in the optimal path to reach the treasure. To do so, we need to solve a Bellman equation to calculate the state value distribution. Here is the policy. This is the state transition probability. Here is the reward, and this is the state value function at next state as a prime. Here is the future discount factor. And we can use the iteration algorithm, or you solve the linear equations to get this distribution. Once we get this distribution, we use the greedy policy. And then from each any state in this grid, we can find the easy way, you can find the optimal way to find the treasure. So here, for example, this state is stand for each cell, and policy is what we search for. Action is under this policy, we search the action right now for actions in action space. And this P is, to transfer from one cell to another, based on this action, what's the reward we got, then to reach the next state. A second one is a hostile environment. That means, for example, in chess or any board game, our opponent move one step, our agent move one step. The goal is in the current situation, we use as the input, we design a policy network. As you use this board image as input, we need to select action because first this is all the how can we select the action? Because we try to understand what's the opponent thinking. If we know how the opponent think, then we can select search for we can find the best policy to select the action to win the game. So that's why we use this policy network select action. In this dynamic environment, we can get the maximum accumulated reward. Here, for example, this select this action, this P, this include include the thinking of our opponent. That's why we try to carefully select this action, make sure we get the maximum reward at each step, and until until we win the game. That means until we reach the terminal. In this case, the policy search, we can learn from export, or we can fight with his previous version to improve the skills. A third one is shared environment. Shared environment, for example, is autonomous driving or robot. There are a lot of road users or other people, robots in the same environment. For the that's the case. In that case, the state include the internal state and observation. We use that as an input to design a policy network. We find the policy A. This environment is dynamic because it's include the road condition, weather, or a lot of, for example, the road users. They are changed, independently. So we need guess, or we need fully understand the environment, then make then select the policy, then search for the policy, search optimal action, make sure in this dynamic environment we can obtain receive a maximum instant reward and accumulated reward. Of course, this environment change with the time, so we need search a new policy at each time. Make sure we always, we can select the optimal action. For the autonomous driving, we can start from an initial point until to the destination point. For the robot program, we move object from initial position to the destination position. That's the basic idea. What's the policies in reinforcement learning? For more details, please check with this reference. Thank you. Bye.